So, of these 5, show me on your hand or hands which number or numbers you want to see you go over, have questions about. And we'll do the majority. So I see a lot of 3s and 5s and 4s. So we'll do those 3. Okay, for number 3, find the rate of change between the given points. That's your slope. So we need to find the slope with your slope formula. Label them if you need to. By doing -5 minus 6 over 6 minus a -5. And then subtract, so -5 minus 6 would give us -11. This would become 6 plus 5, so -11 over 11, which simplifies to be 1. -1. So our rate of change or our slope was -1. Questions on that one before we continue? Number 4, if y1 equals x and y2 equals -1/2 x plus 3, describe the transformations. There are 3. What transformations did we come up with? Go ahead, Sam. What did? The y-intercept shifted up 3. What else, Laura? What is negative? The slope, but it is negative, but what is that word we describe it with? Reflective. There we go. And what was the last thing?
Did it get steeper?
It did not get steeper, but the opposite.
Less
Less steep because of the 1/2. Or 1/2 as steep, 1/2 less steep, any combination of those. And then number 5, find the intercepts, where if you're solving, you could put 0 in for one of the variables and solve for the other variable. So that y is 0, 3. And then the other, I would do the same thing, but put 0 in for y. And solve for x. So that x is -6. So all of the things that we have learned so far will not go away. You need to keep all of that stuff in your mind. Yes.
Number 5, you just divide the y and x by 5.
So you can't just divide it unless there's nothing else there. Because if I just divide this, I have to divide everything. So you have to put 0 in first. That's the only way the intercept works. And then because 0 is there, then you can divide the rest. Otherwise, I'm going to be dividing everything here by 2 or everything here by 4. Other questions there? Okay. So, course calendar, look at that really quickly. I meant to write this on, or type this on this, but I forgot. So I would either write this or keep a mental note. I'm going to move, oh, no, I'm not, because these are due next week. So we're going to briefly start this unit today, but then we're going to finish in next class. The dust mass from this set of notes will be due next week. Remember that you do have dust mass that are due tomorrow. The domain arrangement and context problems do that through Canvas. The 3.1a, the multi-step, is formative. The 3.4 is going to be your real world problems, is also formative. So the two that are due next week will both be formative. The 3.1b, which is going to be multi-step equations with variables on both sides, that one will be informative. The 3.2, which is absolute value, that one will be formative. And then the 3.3, which will be literal equations, that one is informative. So total, you have 3 formative ones and 2 informative ones. And then you see when our quiz and test and flex will be. If at any point something is not making sense, if you're not asking questions in class, you need to be in my office hours the same day or the next morning to come get help as soon as possible. Questions on anything course calendar related? Okay. Look at the notes titled Solving Multi-Step Equations. Can you reach where the timer is? There's a little something that has arrows that looks like this. Yes, thank you. It's like a minimized but not anyway. So the standards for this, there are multiple. Keep those in mind. You can solve multi-step linear equations. So that part shouldn't be too new, but there's also like the verified part of this. So 1, if I asked you what is a solution, what would you tell me? What comes to mind? Sorry.
Like the answer.
Okay. Maddie, what were you going to say? Okay, so sure, the answer. And then in these next ones, we're going to determine if the following values are solutions or not. If let's say I solved this and I got this as an answer at the end, how could I determine if this is the solution or answer to this, Alex? Yes. We're going to take 5 and put it back in. So all the testing that we were just doing for the order pairs is going to come back into play here. I'm going to take that 5, put it in where x is. And I'm going to see, does this make a true statement or not? So if I multiply 13 times 5, will give me 65. And then if I subtract 7, would that give me 58? Yes. So I can say this is a true statement. Now the next one is a negative 5. So because I just found that the positive 5 worked, the negative 5 should not work, but we're going to test it anyway. So now we're going to get a negative 65 minus 7. And negative 65 minus 7 is going to give us negative 72, which clearly does not equal 58. That's not a true statement. This is not the solution. So this is a quick way that when we get into solving, that's what all of this unit is about, solving equations in different formats. This is a great way to double check yourself. I'll show you some other ways. I don't know if we'll have time to do all that today, but throughout this unit. I want you to try 3 and 4 really quickly. No. Did anyone need to see that? Okay. And then for number 4, was that our solution?
Yes. Does anyone need to see that one?
We'll have time to start this next page. I don't know about finishing it, but let's go on. Okay, so at the top are different properties of equality, meaning what we do to one side we have to do to the other, except for the distributive property, because we're just doing that to make the sides equal. So in this, we're looking at what happened between each step. So the first one is always given, whatever the original equation is. And then we're looking at what changed. So from step 1 to step 2, what did they do? Multiplied, not the 9, but the 2 to everything. And that would be our distributive property. Distributive property, where we take whatever is on the outside and we multiply it to everything on the inside. And then from step 2 to step 3, what did they do? Not fun.
Made it plus on both sides.
They added 18 on both sides, so that's your additive property of equality. I'm just going to put add property of equality. And then from step 3 to step 4, they did what by 2 on both sides? Divided, yes. So that's your division property of equality. I'm just going to divide equal. So then for number 2, starting with the given, what did they do next? What changed from step 1 to step 2? Did they do that?
No.
Oh, you said minus 10. Sorry, I thought you said, anyway, yes. Subtract 10 on both sides. So subtraction property of equality. Okay, and then the next, this is what I was thinking about. From step 2 to step 3, what did they do? One.
Multiply by both sides.
So they took that -3 and multiplied on both sides. Multiplicative property of equality or multiplied. Do you have any questions on that part so far? Okay, this is just getting you to recognize that we need to be doing things to both sides. Try number 3 really quickly. This should have been what you got. They multiplied on both sides to get rid of the 2. They added on both sides to get rid of the 1. And they divided on both sides to get rid of the 5. Questions on that? Okay. On the next page, we're going to quickly talk about inverse operations and go through the steps and maybe do one problem. I think that's all we'll have time for. First. So previously I asked, what does it mean to be a solution? You said to give the answer. So now we're going to add to that a little bit. To solve an equation, you have to find a solution by using our properties of equality and inverse operations. So I'm going to word that. To find a solution by using inverse operations. And then just so we're all on the same page, what is the opposite or inverse of addition? Subtraction. What about division? Multiplication. What about to square something?
Square root.
It's the square root. So if you think about like 2 squared is 4, and the square root of 4 is 2, they undo each other. Which means the cube and cube root are inverses or opposites of each other. So 2 cubed, or 2 raised to the 3rd power, is 8, and the cube root of 8 is 2. They undo each other. Okay, so if you get stuck, these are great steps to follow. If you see something you can distribute, do that. If you see like terms, so if they both have the same variable, or they don't both have a variable, they're both a constant, combine them. But only if they're on the same side. We'll talk about that. Move the constant, the number by itself, by adding or subtracting, and then get the variable by itself by multiplying or dividing. Find one question that seems complex or you're not sure where to start, and we'll do that really quickly. Any that stand out that we're like, maybe I'm not sure how to do this? 6, I don't know if we'll have time for today, but I will say there's 2 different ways to go about doing this, and I'll make a mental note that we will start with 6 next class. Okay? So you guys can put iPads up, hold on to all of your notes because we're going to continue it next week. Make sure you guys do your Delta Math. Come see me after school today or tomorrow morning to work on retake work or to get help with Delta Math.